Angle identities, kids. These get really fun.
Yeah, they do. Now,
especially because cosine 2 whatever equals all that.
This can be kind of confusing the first time you see it, I would say. But what's,
I would say too.
What's going on here is we really, if you've noticed, there's a lot of things that can equal a lot of different things,
yes,
right?
That's true.
So basically, with these double angle identities especially, the thing that is most handy for us to change sine of this is saying our angle is 2u.
Right.
Okay.
Right. Or 2 theta or 2 alpha or
whatever your letter
two
is.
variable.
Yeah. But basically, this is what is most helpful usually for us to turn this into.
Right.
Is 2 sine u cosine u. And for tangent 2u, it's normally most helpful for us to turn it into this. But for cosine 2u, it really depends on the situation.
Yep.
And so that's why there's actually, it's like there's 3 different identities. And you don't have to use all 3. Generally, you just use one at a time. But it can make things interesting there with that cosine. You have to use a little knowledge sometimes.
Knowledge
to
of
figure
where
out
you're headed.
which way you want to go whenever you're replacing things.
And here's the deal. With cosine 2u, whatever you pick, if after a step or two there's not any more clear where you should go,
it doesn't seem like it's working,
then
try a different one.
You go back and you try a different one.
Yeah. Now, I like this section, and I like 5.3 also, the proofs at least. I feel like the proofs are a lot more straightforward.
Right.
One thing, though, like on example 1 here, we're trying to prove that sine 2u really is 2 sine u cosine u.
Right.
It's helpful to realize that they want us to use the sum and difference identities
and that's where all this has its root.
Because what we're saying is that if we have twice an angle, so in other words, if we have
sine u plus u.
Yeah, I'm going to go on right.
Oh, okay,
yeah.
okay.
But yeah, but that's where I was going. If we break that up into u plus u, because is it u plus u to u?
Yes, it was this morning.
The last time you checked?
Yes.
This morning?
Yeah.
Okay. So now let's, now this is where it can get kind of tricky. In our sum and difference formula, this is u and this is v.
Oh, wait a second. Hold on.
Like
All
if
right.
you look back at your, at your sine identity.
Right. Right.
That's
what it is.
A page over, or on your unit circle card, hopefully by now.
Right.
So let's fill in.
Let's do it. Sine u, cosine v, which is u.
Right.
And then plus because it's the sine.
Yeah.
Mm-hmm. Cosine u, sine v, which is
but v is u. Oh, I just wrote that wrong.
It's u. Do you get a u?
It's u. Yeah.
It's u.
Okay,
and
so
u.
sine u and cosine u here, even though they're in different orders, those are the same thing.
Yeah. So if I've got one cosine u sine u plus another cosine u sine u, or vice versa, if I've got one and then I have another,
you have 2 of them.
I have 2 of them.
So we have 2 cosine u. Wasn't that just as easy as pi?
Pretty easy as pie.
Okay, so.
All right. Write the expression of sine 2 theta plus cosine theta as 1.
As an expression involving only sine theta and cosine theta. So
we want to get that 2 out from inside.
Right. So I threw this in here because this is kind of tricky if you don't understand what the directions are asking.
Right.
So this is us telling you how this works. They just want us basically to use those identities until all we have is
sine
theta and cosine theta without any numbers in front. So sine 2 theta equals?
2 sine theta cosine theta.
So we switch it out. Do we need to mess with the cosine theta?
I mean, I don't think so because it's still just a cosine theta.
Now, this answer is perfectly fine. If you wanted to factor out the cosine theta and do that, that would be fine.
That'd probably be a good skill to maybe try.
Like make sure that
because there are times when you will need to be able to do this.
Right. They both have cosine theta, so you can factor it out, and that leaves you with 2 sine theta in the first part.
Plus 1.
Plus 1, because if you take out, like we have a cosine, we took it out, but we have to put a placeholder there so that if we were to come back and distribute, it would work out.
Right.
So that's a pretty simple problem. Just the instructions are a little wibbly wobbly if you don't know what you're doing. And then we've got some problems where we're proving identities, kind of like example 1 was, but I feel like a little trickier than example 1.
Yeah,
so I thought we'd give this a try.
A little more fun.
Because this is 3x, and we only know what sine of 2x is.
I have a thought.
Yeah.
Could we do it sine 2x plus x?
I think that would be a good way to go, because we're saying basically that, hey, I can split 3x up into 2x plus x, Well, now I can use that
sum or difference
identity.
You can't go right into the double angle identity here.
No,
because
you have to do some work first.
You got to do some work first.
So this is our u, and this is our v, and the sum and difference of sine.
So sine 2x cosine x plus cosine 2x sine x. Man, I'm doing that without even looking at my circle card.
That's impressive.
Yeah.
Now we have some 2x's in here. So now we can start using those handy-dandy double angle formulas.
And sine 2x is only one of those.
Yeah.
2 sine x cosine x. Now, this is where it gets challenging, and maybe you need to have an eraser close by, because
I know where my eraser is today, so just in case.
Okay, so when you work with cosine 2x, you've got three choices, and basically we can't tell you which one specifically to shoot for.
Every single time. There's not a right answer.
Right.
Because it really depends on what are we trying to get to on this right side.
So Mrs. Stevenson drew an arrow. We need some sort of cosine squared thing.
Situation. So the one that has cosine squared minus sine squared, I'm thinking not so much.
I don't really see a sine squared over there, so I wouldn't pick it myself.
No. And same with the 1 minus 2 sine squared.
Right, because there's no sine squared,
So let's try 2 cosine squared u minus 1.
Yeah, let's try there, because that actually gives us the cosine squared part only, which is what we're mostly interested in right now. Now, we could be wrong. We could be wrong,
but we're trying.
But this is how we're going to start it. You have to start it to find out.
Yes. Okay, so now this is kind of a tricky algebra situation, maybe, because, we've got 2 sine x cosine x. We can really just drop those parentheses and say that's 2 sine x cosine squared x.
I like it. Okay, so we're distributing cosine x.
Yeah, and then, there's a couple different ways algebraically we can go with this, but I recommend going ahead and distributing.
No, that's a good plan. That's actually the best plan.
Okay.
I wouldn't even recommend that there are a couple of ways. There is one way, and that is to distribute sine x.
We'll have to agree to disagree. You could
but only if you want to be wrong.
You could shoot for it a different way. So we distributed sine x. Now, notice that everything has a sine x. And also, we have like terms.
Mm-hmm.
So in whichever order you personally want to do that, let's go ahead, I guess, and add these.
If I have 2 and another 2, and I put them together for 4.
That's an impressive trick you just did there.
Got a million of them.
Million tricks or a million fingers?
Both. It's really weird.
Now you're just making stuff up. I thought this was like a truth show.
This is a truth show. Look, you're going to factor out a sine x, and now we have the truth that sine 3x equals sine x times 4 cosine squared x minus 1.
Right.
Oh, yeah. I love trig identities. I love proving these things. They're so fun. Smiley face Minecraft.
I have a student who's drawing turtles at the end of all of his proofs.
Turtles are good.
Turtles are absolutely
Teenage
fabulous.
Mutant Ninja Turtles.
No, regular turtles.
Oh, regular turtles.
But that would be cool too.
Power reducing identities. Now,
if you're a superhero, you would not want to tangle with the power reducing identities.
Why not, Mrs. Stevenson?
Because they would reduce your powers as a superhero.
Ha. That was a good one.
Can we make that the code word?
Yeah, code word, superhero.
Code word, superhero.
I don't know about you, but math skills. I'm a teacher. That is my superpower. I teach.
Yeah, I teach math.
I teach math.
Yeah, it's a pretty powerful thing. Example
pretty
2.
Powerful.
Okay, well, these are fairly straightforward, I feel like, as far as identities go.
Yeah,
and
they are straightforward. Mm-hmm.
Notice if you power reduce, you end up with a cosine 2u, and potentially, depending on what the situation is, you could then use like a half angle identity.
A double angle identity.
Yeah, that's what I meant. Yes. Double angle identity. So
I knew that's what you meant.
I don't think that that's actually going to be something we have to do. We just could if we wanted to. There's a couple different ways we can go with this proof.
I think factor.
Okay, so you think we should factor cosine to the 4th theta minus sine to the 4th theta into...
Yes, because when I look at that, I see x to the 4th minus u to the 4th, and I would want to break that up into small pieces.
I don't like the way I started this. I'm going to write down the left side, then I'm going to go from there.
Okay. All right. Whatever you need to do, Mrs. K. Steve.
Okay. Here we go. So squared plus
Yep.
Squared minus.
Now, the reason I would personally choose to do this, number one, I've got tons of experience, and I like these.
Tons of experience.
Tons. Thank you. That was
What's the other
really
reason?
polite. The other reason is I just like trying stuff out. And I try what I see first, and if I don't like it, I'm not afraid to erase. So I'm not afraid to make that mistake right here.
Yes. If you want to know another way to do it, like the next example, we can actually talk about what the other way to do this problem would be.
There's another way?
There's another way. But let's not worry about it. Let's do it this way.
Well, I like cosine squared plus sine squared too, because if you can get cosine squared plus sine squared, that's a 1.
That is 1. This first parentheses is 1.
That makes life so much easier now. We've gotten rid of a whole thing.
Yeah, a whole factor.
Yeah.
And now there's 2 ways we could go about this, maybe, but the best way to go from here is cosine squared theta minus sine squared theta. It now has an identity. Before, if it was a minus sign, we were out of luck. But look
What,
at
it
our
has an
double angle
identity?
identities. Cosine squared u minus sine squared u equals cosine 2u.
Oh, look at that. And I was going to say, let's try our power reducers and combine like fractions and such.
Yeah,
Did I
we
steal
don't
your
have
thunder?
to do that.
Did I steal your thunder on that?
No.
No?
No.
Okay.
No, that's fine. There is a way of doing this with power reducing identities.
Well, let's just do it, and let's just work it out both ways.
Are you sure? Because the next example will kind of take care of
Let's
that.
practice.
Let's practice.
Yeah.
Let's practice.
Why are you saying that about practicing trig identities? This is one of the most exciting things that we do all year.
Don't say that.
Why is it not? Why are we disagreeing in public now? We are one mind.
Keep in mind that to the 4th power could also be considered a squared.
Yes.
And so if we think of it like that, then cosine squared we could change to 1 plus cosine 2u over 2 and put that in the parentheses.
Right.
But we're squaring it.
Right.
And then sine
Same
squared.
thing.
Same thing.
Except the whole thing will now be squared.
And then we would FOIL.
And
on
this
top,
FOIL,
1 plus cosine 2 theta times 1 plus cosine 2 theta.
Now, remember your FOIL tricks. There's no need to write out this whole thing. Square the first term, then take 2 times the first term times the second term, and then square the second term. And that's all there. Okay? But notice Mrs. Stevenson did not write 4 theta anywhere. Okay? That doesn't change.
No, the 2 theta stays what it was.
Yeah, it's gotta stay
We're
that
doing
way.
cosine 2 theta times cosine 2 theta,
Right.
which is cosine squared 2 theta.
Now, can I be so bold as to say we're going to have a common... Oh, you're going to split it up? Okay.
I was-
Never mind. Split it up. Go ahead.
Oh,
You're fine.
Okay.
I was going to go ahead and on my paper, I would have gone ahead and combined all of this over the 4. But you're good.
to some u's here on accident. Whoopsie. That doesn't even look like
That's
a
a
theta anymore.
There we go. And there we go. Theta. Okay. Plus.
Cosine squared 2. Oh no, I'm about to write on our
we're
faces.
going to write on our face.
Okay, we're good.
We're good. Yeah. Dodged that one. Now,
There is a common denominator.
there is a common denominator. It's 4.
And we are subtracting.
Yes. So
So we have 1 minus 1.
0.
We have 2 cosine 2 theta plus 2 cosine 2 theta.
4 cosine 2 theta.
We have cosine squared 2 theta minus cosine squared 2 theta
0.
all over 4
And the 4's cancel.
so that we get cosine 2 theta.
There you go.
That's
There you
the
go.
power reducing way of doing
So
that.
there really was 2 different ways to solve
I'm
it.
telling you, like on every single one of these, there's multiple ways to do it.
Wow. Who knew?
I did.
Okay.
Now you do.
Now I do too.
Now you do.
All right.
Rewrite cosine to the 4th x in terms of trigonometric functions with no power greater than 1. So in other words, it can be cosine x or sine x, but it cannot be cosine squared x, cosine cubed x, cosine to the 4th x.
Sounds good. Let's dive in, shall we? I smell a power reducer coming our way.
I do, and since we...
Twice, potentially.
Yeah, since we kind of already covered this in the last example, that cosine to the 4th power we could say is cosine squared x squared, or you
Right.
could just write cosine squared twice.
You could.
Whatever way you want to do that.
You know, I've done it both ways.
I have too. So what do we want to change cosine squared into?
Something that doesn't have a squared in it.
Oh, wait, this doesn't have, like, multiple things. I was thinking of the other identities.
Oh,
cosine
okay.
squared is 1
One
plus
plus
cosine 2u?
Yeah, 1 plus, well, yeah. Cosine squared is 1 plus cosine 2u over 2. 2x. 1 plus cosine 2x
2x
over 2.
over 2 squared.
Squared,
So
right.
let's square that, shall we?
I feel like if we square it, we're going to have a squared again, and we're trying to get rid of those.
Yeah, and then we can probably use a power reducing identity again.
Yeah, that's what I said already.
Oh, then why are...
There it is right there, cosine squared 2x. Now notice, on none of this did Mrs. Stevenson write down 4x anywhere, because that 2x stays 2x the whole way through the problem.
Yeah, you can't, like,
okay?
combine those two.
We did nothing to the x inside.
Now, this is a tricky problem mostly because of, like, the fractions. Like, this 4 on the bottom, we could rewrite this as 1/4 times and then
That's
not...
probably the best idea, actually, to help keep things organized.
Yeah.
Yeah, it's a good plan.
Because when we replace this cosine squared 2x with the power reducing identity, we're going to end up with another fraction.
Right.
A fraction on top of a fraction is not really the ideal situation.
Little tricksy.
Okay, so let's do that. Let's replace. So 1/4 times 1 plus 2 cosine 2x plus...
And then the exact same thing. 1 plus cosine 2x over 2.
Except we already have a 2x.
It's got... So 2 times 2x.
Which is 4x.
Yeah. Over 2.
But there's no squared in that situation.
There's no squared.
Because there's not a second, like this we were squaring something that was
Yeah,
squared.
there's nothing being squared in this.
Right, and so in case you missed that, let's do this in slow-mo. We have cosine squared of theta, where theta is 2x.
Right.
Okay, and so we are using our power reducing identity here to change, but then we put the theta back in
right.
so that we have 2 times 2x. That's how we're getting that 4x there.
Yep.
All right.
Now it does change to 4x in this situation because of what Mrs. Stevenson just showed you. That's why we don't have a 4x in a previous situation, because we're dealing with an angle that just has x.
Right. So now, what should we do?
Let's distribute the 1/4 and call it pretty.
Okay. So
1/4
plus
1/2. Yes, cosine 2x plus 1 plus cosine 4x over 8.
Now, are you sure that's the best answer?
I mean, I'm comfortable with that
Okay.
answer. You could factor out an 1/8, I guess, if you wanted to be like uber cool.
Or you could split this up into 1/8 plus 1/8
Oh, yes,
cosine
yeah.
4x, because this 1/8 and that 1/4 can
Go together.
Yeah.
So that'd be 2/4 plus 2/8 plus that'd be 3/8.
And this is why we like identities better than open-ended questions. 1/4 plus 1/8, you change this to 2 over 8. It's 3/8. Did you already say that?
Yeah, I did. I said
Oh, my
3/8,
bad.
yeah.
I was thinking about other stuff.
You were. That's okay, though. Brilliant.
Yeah. 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 Half angle identities. These
Okay.
are, like the double angle, but like not.
But half-Cs.
Half-Cs.
And they, on their own, are a little bit more trickeration, I think.
Yes.
Because of the whole square rooting issue.
Yes. Now, I will say we're not really going to prove a whole lot with them. Okay, but we're going to actually use them to work out some stuff, kind of like we did with the sum and difference identities. We used it to help us work out some stuff. So the thing you have to know, these plus or minuses, does not mean it's an actual plus or minus situation. It means that we have to figure out for ourselves whether it's a plus or a minus.
By figuring out exactly where we're at on the unit circle.
Yes, so your answer should not be...
Plus or minus blah, 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 blah.
Yeah. And so because of this, I will say if we have this situation where you can pick whichever one for tangent, so I would tell you that if you're simply evaluating, that this is the one to use. If you're trying to prove, it depends on what you're trying to prove. But if you're trying to evaluate, This one right here, it avoids the plus or minus situation, and it also will be the nicest to
deal with, actually.
deal with, yeah, because you won't have a huge square root to deal with.
Right. The denominator's one
yeah,
item.
Yeah, because if we ended up with a fraction down here on the denominator, that'd be bad. So
No.
let's not even worry
Why
about
are you even
it.
bringing that up?
I don't know.
Oh.
So, to use the half-angle identities to find something like sine of 105 degrees. First off, we could find this with the sum and difference identities. Did you know that?
105?
Yeah.
Shut the front door.
You could. You could do sine of 45 plus 60.
What? That's 105.
Right, but we want to practice with the half-angle
Okay, let's do it.
identities.
Let's do
so
half angle.
make sure that you're paying attention to...
Half of 210. It's half of 210.
Right, okay. Well, make sure you're paying attention to the instructions so you know which identities to use. But Mr. Hazelwood is right. For part A, the way this works is that we are changing this into basically twice as much.
Right.
Right?
Because
So
we
we're
want our half angle to reduce to the angle
What am I
given
writing?
to us. So we were given 105 degrees.
Right.
We want what we work with to reduce by 2 to 105
Right,
degrees.
so that it matches this, because now we know what you would be.
Mm-hmm.
You would be 210.
Yeah, I like it. I like it.
So now let's pause for a moment and figure out if it's a plus or a minus. And the way we do that is we need to think about sine of 105 degrees on like our unit circle.
That's going to be
Second
second quadrant.
And in the second quadrant, sine is positive.
Yes,
So that means that we will have a positive square root.
I like it.
And then we fill in,
All the rest of the goodies.
and then we just do some simplification. Cosine of 210 is on the unit circle and we can find it.
Cosine 210, that's going to be, so here, 210's like right there, 1/2.
I was going to go with negative square root of 3 over 2.
So,
Because 30 degrees cosine.
oh, I was in the wrong quadrant.
You're in
sorry.
the wrong quadrant.
I was in second quadrant
Okay.
instead of third. My bad.
Don't let it happen again.
Yeah, whoopsie.
So it's negative and then negative square root of 3 over 2. So that's plus.
Square root of 3 over 2. Over 2.
Okay, so
Don't leave it like that.
we gotta fix
We're
the
going to
fractions.
practice some algebra here.
So you do a common denominator of 2.
Yep,
So
mad
we
skills.
change this to 2 over 2. So that's 2 plus the square root of 3 over 2 over 2, which is like 2 over 1.
Right.
So you flip it up.
Multiply by the reciprocal, just like you did in kindergarten.
That's not
What?
what you did in kindergarten.
First grade.
You know, they've
This
changed
new Common
things
Core
up.
thing, you know, that's pushing it all down a little further.
You can't take the square root of 2 plus the square root of 3, but you can take the square root of 4.
Yes, you can. And we're done. Now, notice that
This is an unpleasant looking
it's
answer.
very unpleasant looking, but
it's
all-
correct.
it's correct, and it's a lot cleaner than the answer right above it, which is where you will not stop.
Yes, exactly. This
Yes,
is no...
reduce everything
yeah.
under the radical, and we're going to do that because it's good practice algebraically.
Right. Cosine, 7 pi over 8. There's one of two ways we can do this. We can
Really? One of
double
two?
this and get 7 pi over 4 and use that, or we
Ooh.
could convert and just not even worry about the
Let's
radian.
do 7 pi. Let's do radians. We need radians. Radians are good for us. They build character. And notice 7 pi over 4 over 2 reduces all the way down to 7 pi over 8.
It does. I just multiplied this by 2 to figure out what to use, and so I canceled out 2. Now, where is 7 pi over 8? It's almost 1 pi.
Second quadrant.
Second quadrant, is cosine positive or negative in the
It
second
is
quadrant?
negativo.
So our
Second
answer
quadrant,
will be
negativo.
negative with the square root. So let's simplify.
Cosine of 7 pi over 4 is the square root of 2 over 2.
And it is positive, in case, I don't know, you were worried that it is positive.
It's negative.
No, this is, it was positive square root of 2 over 2.
Cosine?
7 pi over 4.
It's
Cosine of
cosine.
7 pi over 4.
Cosine's negative in second quadrant.
It's not in the second.
That's what I said. It's in the third quadrant,
It's
which
in
is
the fourth
positive.
quadrant.
That's 2 in a row that I've had in the wrong quadrant. This is really bad.
What
Especially
are we
with
even
all of
doing
my.
right
what
now?
what are we doing right now?
Common denominators.
I was thinking of 7 pi over 8.
Yes, I was a little suspicious there that that's what was happening. So we flip up the 2 over 1 and get 2 plus the square root of 2
over 4.
over 4.
And again, we can't take the square root of 2 plus the square root of 2, so it stays in there. But we can take the square root of, we could take the square root of 4, which is 2.
That's a lot of 2's.
It's a lot of 2's. Minecraft guy, and we're done.
We're
we
not
didn't prove.
proving.
Sorry, no Minecraft guy.
Tangent of 22.5. So we have to multiply this by 2 to figure out what angle to use.
45. Thank goodness, that's 1.
It is.
But don't you dare write it because you have to do the whole half angle process.
So let's use the one that I started.
I like that. I like that. Okay, I know the cosine of 45 degrees is square root of 2 over 2.
So we got 1 minus square root of 2 over 2.
Divided by square root of 2 over 2.
Square root of 2 over 2. So to simplify...
Multiply by the reciprocal.
Okay. So we're doing 1 minus the square root of 2 over 2 times...
2 over the square root of 2.
over the square root of 2.
Don't, and if you're one of those rationalized folks, I wouldn't rationalize here. I would rationalize at the end.
Yeah, because if you distribute this, you get 2 over the square root of 2 minus, these are the same thing, just
So it's
opposite.
a 1.
So it's 1.
Yeah.
So if you wanted to rationalize this now, you would have...
2 square roots of 2 over 2, which is
square root of 2. That's a pretty good answer.
So you could stop there, or you could stop at 2 over radical 2 minus 1. Like,
Yes,
that's
you
a safe
could.
place to stop as well.
You could.
Okay.